In this video, we're going to take a look at one thing that's a little tricky sometimes when it comes to learning about aromatic compounds. It's those atoms like oxygen, nitrogen, and sulfur that have lone pairs of electrons. It seems like sometimes they're included in the aromatic system, sometimes they're not. How do you tell? So that's what this video is about. Let's jump right in. So let's start and look at two aromatic compounds, furan and thiophene, that have oxygen or sulfur atoms in them, and these lone pairs of electrons. I think once you can understand how those lone pairs of electrons are involved in these systems, it'll make sense for a lot of other compounds. Let's look at furan first. It's a 5-membered ring with a couple of pi bonds and some lone pairs of electrons. Let's look at how the pi system of this is set up. I'm going to take this and I'm going to draw it on its side. So here are my pi bonds, and there's two lone pairs of electrons on the oxygen. Here's a double bond, a sigma bond and a pi bond. Now the pi bond is made of two p orbitals that overlap. Each one has one of these electrons to make the pi bond of the double bond. Here's another pi bond. So it is also two p orbitals that overlap that hold those two electrons, the second bond that we're drawing. Now, in order for this ring to be aromatic, this oxygen also needs a p orbital. And if it has a p orbital, that means there's also 3 bonds, an sp2 hybridized orbital on there. So 2 of these electrons are in the pi system in the p orbital, and the other 2 electrons are in the sp2 orbital. So in the pi system, we have these 2 electrons for this pi bond, these 2 electrons for this pi bond, and these 2 electrons in this p orbital on the oxygen for 6 pi electrons. That's equal to 4 times an integer plus 2, 4n plus 2. If this is 1, it'd be 4 times 1 plus 2 is 6. That makes this aromatic. So it's aromatic, and only 2 of these electrons, of these 4 electrons on the oxygen, are in the pi system. The other 2 stick out sideways. It's the same for the thiophene. So let's draw this sulfur compound. So every time you see the pi bond, you draw your p orbitals, and they overlap to make that pi bond. Here's a pi bond. So these overlap to make this pi bond. So this sulfur, in order to be conjugated all the way around and make this aromatic, has a p orbital. And so let's see, 2 electrons will be in that p orbital, and the other 2 will be in this sp2 hybrid orbital sticking out sideways. So we have 2, 4, 6 pi electrons. That's 4n plus 2, and this is an aromatic ring. So only 2 of those 4 sulfur electrons are in the pi system. Let's look at some nitrogen compounds. This nitrogen ring with some double bonds in it is called pyridine. And this nitrogen 5-membered ring with an NH and 2 double bonds is called pyrrole. So let's look at pyridine and look at its pi system. I'm going to draw pyridine on its side. So we have a pi bond, and a pi bond. All right, so let's draw in our p orbitals for our pi bonds first. So here's one pi bond that overlaps, holding those 2 electrons. Here's p orbitals for this pi bond holding those 2 electrons. And here's a 2 p orbitals, a pi bond that hold these 2 electrons. I still haven't put my lone pair of electrons in yet. So they're in this sideways sp2 hybrid orbital. They are not involved in the pi system. They're sticking out sideways. How about pyrrole? Well, let's see if I can draw this 5-membered ring. So let's take care of the pi bonds first. Here's a pi bond holding 2 electrons. Here's a pi bond holding 2 electrons. So this nitrogen needs a p orbital, and it must hold those 2 electrons in the p orbital. So we have 2, 4, 6 pi electrons in its system. This one has 2, 4, 6 pi electrons in its system. Both are aromatic, 4n plus 2. Now this one, how did I know these 2 electrons weren't in these p orbitals? Well, these p orbitals were already full with this pi bond. They already had 2 electrons in it. So there's no room, if it's already full with 2 electrons, for 2 more to fit in. That's why they had to go out sideways. Here, this p orbital did not have a pi bond in it. That's why the lone pair can go into those p orbitals. Now let's say I have, an acid in here, an H+. If I have an acid, which negative electrons are most likely to go react with it? Well, how about these 2 electrons? Well, I need these 2 to get to my 6 electrons to make this aromatic. So they're busy making this ring aromatic. Are these electrons making this ring aromatic? Of course not. These 6 electrons, 2, 4, 6 in the pi system, make it aromatic. These 2 are doing nothing to make it aromatic. So they can go and react with an acid. So that means we would call these 2 electrons basic because they act like a base and they can go react with an acid. These are not basic. They would not go and react with an H+ of an acid. So that's how you can tell. That's another way of asking, are these electrons in the aromatic system or not? If they're not, we say they're basic. If they are, we say they're not basic. So nitrogen rings, nitrogen amines, let's make triethylamine. If there's an acid, these electrons can go react. So most amines are basic. The only time they're not, or one of the times they're not, is when those electrons, instead of being available to go react with your acid, if they're involved with the pi system, then they're not going to be basic. Let's look at one more big compound with a bunch of nitrogens in it and see which of the nitrogens we think are basic and which ones we think are not basic. So this is adenine. It's a base in DNA, and it's got 1, 2, 3, 4, 5 different nitrogen atoms. And let's take a look at all 5 nitrogen atoms and see if we think the electrons in each of those nitrogens would be basic or not basic. And I think if you can do a problem like this, you can handle just about any of these. All right, so let's look at each of these nitrogen atoms. They each have a lone pair of electrons. They all have 3 bonds and 1 lone pair of electrons. So the trick is, are those electrons in the pi system or are they sticking out sideways? So let's take a look. I like to look at every pi bond first and fill it up with its electrons to make a pi bond. So here's a pi bond, the double bond. It's filling up those 2 p orbitals. Here's a pi bond. It fills up these 2 p orbitals. Here's a pi bond on this carbon and nitrogen, filling up those 2 p orbitals. And here's a pi bond on a carbon and nitrogen, filling up those 2 p orbitals. Okay, so in order to make this ring aromatic, this nitrogen also must have a p orbital. I need to have a ring that's flat, that's conjugated all the way around. So all of these p orbitals all had pi bonds in it. How about this one? Is there a pi bond in there? No, there's not. That means these 2 electrons are actually in that p orbital in the pi system. That means this ring has 2, 4, 6 pi electrons, aromatic. This ring has 2, 4, 6 electrons in it, and aromatic. Now that we've seen where all of the electrons are in the pi system, all of these other p orbitals, or all these other lone pairs of electrons, are in sp2 hybrid orbitals. They stick out sideways. And these 2 electrons are probably just in an sp3 hybrid orbital with 4 things on it. But none of them are in pi systems. So that means if there's an H+ out here, an acid, well, these could go react with it. That means they're basic. These could go react with an H+. So they're basic. These could go react with an H+. So they're basic. They can because they're not involved with the red pi system. Here's an H+ acid. These could go react with it. They're basic. Here's an H+. Can these 2 electrons go react with that? They cannot because they're being used in the pi system. So these are not basic. They're the only ones out of all of those nitrogens that are not basic. So in the ring system, those with double bonds on the nitrogens were basic, and that one without a double bond on it was not basic. Now, some people think, well, if there's a double bond on the nitrogen, that must mean it's basic. Sometimes, if they're in a ring, but notice this nitrogen does not have a double bond on it, and they're also basic. So the key is, if it's in a ring and it's part of an aromatic system, then the lone pair you have to see, does it need to go up into the p orbital, or is the p orbital on that nitrogen already full with a double bond, therefore they have to stick out sideways. I use the word basic and not basic there a lot. I hope it makes sense. They're basic if they can go react with the H+, but if they're part of my pi system, then they cannot go react with the H+. They're going to be held in the aromatic system. Then they can't go out and do that reaction. They are not basic. Please subscribe to the channel so I can continue to help you with your organic chemistry.